Shall we start?
Yes, sir.
Okay.
Earlier lecture, I discussed about the electrical instrument tray, piping for instrumentation, statutory requirements, critical examination technique. Now, last point, that is a miscellaneous. So, what is miscellaneous in piping arrangement? In miscellaneous, the space requirement of HVAC ducting where applicable shall be integrated into layout at the stage of development. So here we are consider the HVAC, that is HVAC. What it stands for HVAC? Heating, ventilation and air conditioning. What is the use of heating, ventilation and air conditioning? Yes, anyone? Yes. What is heating, ventilation and air conditioning? What is the purpose in industry? Yes, anyone? Amar? Yes, Atharv?
Yes, sir.
So, what is the purpose of heating, ventilation, and air conditioning in industry? We have studied refrigeration and air conditioning.
To carry away the exhaust gases.
Okay, very good. Or Aniket? Karthik? Rakesh?
Sir, to filter out the air and maintain the temperature of the room.
Very good, very good. Now, heating, ventilation, and air conditioning is the use of various technology to control the temperature, humidity, and purity of the air in an enclosed space. And along with heating and cooling, both residential and commercial buildings. They are the systems that keep you warm and cozy in the winter and feeling cool and fresh in the summer. So as far as concerned, the use for the commercial and residential buildings. And as far as concerned, in enclosed space in industry, so you can use this kind of technology and we can control the temperature, humidity, and purity of the air in an enclosed space. So its goal is to provide thermal comfort and acceptable indoor air quality. So about the HVAC heating, ventilation, and air conditioning system. So then HVAC ducting where applicable shall be integrated into the layout at the stage of developments. The equipment for these will be housed separately and should include in the overall plot plan. The dimensional requirements of ladders, stairways, trenches, platforms are to be used to considered while making equipment arrangement and planning access to walls and instruments. Walls and instruments. And the plant, the various structural elevations are determined by the guidelines for the requirement of headrooms given above. The size, the supporting beams should also be taken into account while finalizing the structural labels. And the edge of the yard with orifice flange near a rack column for access with portable ladders. So Orifice runs after pumps and can be located near supporting column, the plant. Generally, the process lines that connects two lines located at a level higher than the top tire should run on the top tire of the rack, and lines having one end located at elevation lower than the bottom. The tire can run in the top or bottom tires. If both ends of the line are lower than bottom tires, the line should run on bottom tire of the tanks. Now we'll start next parameter, that is pump. So here I will share next slide, and now the pumps. So basically the pumps are rarely influence the plant layout except where a common standby for two services or multiple duty pumps might take the process equipment arrangement, but the pumps can never be treated as an independent entity, but to be treated as a part of the piping system, which affects the performance even if the basic selection is faultless. Then, types of pumps. What are the types of the pumps? Before looking into the layout and piping details of the pump, so here you can see the equipment layout, the pumps in refinery or petrochemical industries. Basically, there are two types of pumps. First one is the centrifugal type, and second one the positive displacement types. The centrifugal type could be a single stage or multi-stage. Is it correct? What we have studied the pumps in fluid mechanics. Centrifugal type could be single or multi-stage. The single stage pump has one impeller and multi-stage pump has two or more impellers in series. The discharge of the one impeller is the suction of the next one, and the head developed in all the stages are located. Based on the suction and discharge arrangement, the type of pumps available are end suction top suction discharge, and side suction side discharge. So there are three types of suction and discharge arrangement type of pumps are available in refinery or petrochemical plants. The end suction top discharge pump has vertical split casing, and the end suction end discharge pump has horizontally split casing. See the difference. End suction top discharge and end suction end discharge. Top discharge and end discharge. The vertical split and horizontal split. Vertical split casing has good vertical spacing, has good maintenance access. They are normally the back pull out design, which facilitates the removal of impellers without affecting the piping connections. Pumps will be mounted on a base plate with motor, keeping this base keeping this motor shaft and pump shaft carefully aligned. This base plate will be ground one to concrete foundation. The size of this foundation shall be approximately 500 by 1500 millimeters, or can vary up to 20,000 millimeter long in case of large pumps. Large capacity water pumps usually have horizontally split casings. Inlet and outlet are horizontal at right angles to the pump. Section piping should be short and straight with one or two expansion joints. Inline pumps are compact and mounted along with pipelines even overhead. Larger inline pumps may need separate supported on vertical shafts. Pump occupy less area but needs headroom for removal. The positive displacement pump can be rotary or a reciprocating type. The rotary pump work with force volume displacement and can deliver constant pulsion of free flow against higher head than the centrifugal pumps. The layout and piping design do not differ from that of the centrifugal pumps. Reciprocating pumps are used where very high head is needed for low flow. Here, the discharge cannot be throttled to obtain capacity control as in the case of centrifugal pumps. Instead, a variable speed drive stroke adjustment is used. The alternating action of reciprocating pumps produce pulsion flow. Extent and frequency of pulsions depends upon the number of cylinders in parallel and whether they are single or double actings. Due to pulsing operation, these pumps are bulky but are considered for very low flow applications. The pumps could be single acting with single piston plunger with very high pulsing flow. The variation in cylinder arrangement gives single, duplex, triplex, and quadruplex pumps. The diaphragm pumps are compact and deliver precise quantities of fluids. The positive displacement pumps are not suitable for pumping slurries and are not suitable for abrasive services. Now, see the next parameter is equipment layout. In equipment layouts, the design of equipment and piping configuration affects the energy use and capital cost of pumps. Hence, the economy of pipings and structures, along with ease of operation and maintenance, are the principles and aim while arranging the pumps. Pumps are placed close to process vessels. Number of pumps should be lined up and aesthetically well arranged. Pumps are arranged under the pipe rack in a refinery or an outdoor process plant. Outdoor process plants, keeping motor end towards the access space and section discharge faces towards the process variables. Single pump should have access all around a minimum of 900 millimeters. When space is restricted or the pumps are small, two pumps can be placed on common foundation with the orientation of the motor terminal modified if required. See here, you can see the modified motor terminals here. This pump arrangements, single pump arrangement and another you can consider that is a paired pump arrangements. So here space is provided on the common foundation while the orientation of the motor terminals modified if required. For safety and operator convenience, another parameter is as far as concerned the safety and parameters parameters convenience pumps for tanks containing inflammable or corrosive liquid should be located outside the dikes. So here we can locate the outside the dikes for safety and operator convenience. Pumps for tanks containing inflammable or corrosive liquid should be located outside the dikes. Now, next parameter is piping arrangements. In piping arrangement, primary goal in piping arrangement is to satisfy the performance and flexibility requirements. Suction piping should be designed without loops or pockets. The eccentric reducer placed close to the suction nozzle, other FSU or FSD means face side upper. So here the eccentric reducer, that is a face side upper, or we can use FSD, that face out down, this parallel side. This reducer we call the face side upper. If it is lower, then we call the face side down of eccentric reducers, depending upon the line configuration. So here we have to consider the line configurations. Then and then we can go for the face side upper or face side down for eccentric reducers. This line shall be drainable near the pumps. The suction is generally one or two sizes larger than the pump section nozzle for centrifugal pumps. Now, next requirement is NPSH requirement. It's a nominal size of header requirement has to be checked while locating the pumps and routing the section lines. Accordingly, saturated liquid, steam condensate, and vacuum conditions need elevated section vessels. The horizontal run should be kept minimum in all section pipes. So here you can see the lines for face side down, eccentric reducer for face side down, pumps with section vessel above. So accordingly, saturated liquids, steam condensate, and vacuum condition need elevated section vessels. The horizontal run should be kept minimum in all section pipes. The thermal expansion requirement should be taken care of in such a way that the pump nozzles are not loaded. The section as well as the discharge piping shall be supported adequate enough not to impose excess forces and moments due to dead weight and pipe expansion. The check valves are placed on the discharge piping to arrest the backflow and reverse run up the impeller due to it. So here we can see the discharge piping arrangements. So if the check valve is piston lip type, then the piping should be arranged horizontally, and if it is swing type, it can be placed vertically. The streamline piping is desirable at section and discharge piping of reciprocating pumps. Use long radius bend and angular branch connection to avoid sudden change of direction and opposing flows. So here we can refer these figures for sudden change direction. Spool pieces shall be provided to facilitate pumps removal because the maintenance requirement is relatively frequent. If the pumps are designed to do the multiple duty, the section manifold and the discharge manifold shall be arranged nearer to the pumps to make it operator friendly. So here you can see the different piping fitting components. Here first one is pipe ends, that is 90-degree turns, and right side elbows and pipe bends. The help of these fitting components, we can change the direction and opposing the flow with the help of these piping fitting components. So then we can consider the convenient branches and streamlined branches in piping layouts. Auxiliary manifolds to supply cooling waters, steel flushing fluid, gland oil for pump circuits. Heating or cooling shall be located overhead and nearer to the pumps. The complexity of piping system design, maintenance, and troubleshooting requires the process engineer, the maintenance engineer, and the piping engineer on the same wavelength and work more closely together. So this is all about the pumps. Do you have any questions, any doubts regarding pumps and equipment layout of pumps, piping arrangement of pumps? Yes, do you have any questions, any doubts? Yes, Suraj, Aditi, Abhishek.
No, sir, no doubts.
Okay. Then we'll see the next components, that is compressors, heat exchanger, and equipment layout of heat exchangers. So now start with compressors. Basically, there are two types of compressors used in the chemical process industries. They are the centrifugal type and reciprocating types. Layout and piping consideration for the centrifugal compressor do not differ in in concept from arrangement of centrifugal pumps. However, pipe sizes are much larger. Why pipe sizes are much larger? Because the large volume handled, the, these have horizontally split casings and having bottom connections are elevated. Concrete column and tabletop arrangements are provided with surrounding access platform. Compressor foundations are kept independent of building foundations. The hand-operated traveling crane located at compressor center. Line is to be provided overhead. The laydown space also has to be planned for. Knockout drums and interspace exchanger are also arranged so as to have short and simple pipings. Long radius elbow should be used immediately before the compressor section. A straight length of 5D, that is 5 into diameter at the section, is normally provided. For air compressor, strainer has to be provided at the open and lubricating oil, seal oil Consoles are also to be located which occupy large area near or under the compressors. Manufacturer's recommendation should be followed in this case. The reciprocating compressors are located on concrete foundation at grade level and not concrete tabletop. The basis of a laydown area, foundation, and the roof above are identical to that of centrifugal machines. The piping interconnecting the pulsation dampers, intercoolers, aftercoolers should be short and simple to reduce the vibrations. It is advisable to provide a vibration damper. It is also called expansion bellow at the outlet of the compressor. Sufficient straight lane shall be provided after the discharge to avoid back pressure. To avoid vibration flow, the customary piping details can be modified like use bends instead of elbows. Second parameter is use angular inlets instead of laterals. Then use smooth junction instead of head on opposing flow. And then use streamline end of heater arrangement instead of dead end headers. So you can see kind of arrangements in compressors. So we have to avoid the discharge, to avoid back pressures, to avoid vibration due to plunging flow. Then we have to adopt or we can modify the system using bends instead of elbows, angular inlets instead of laterals, smooth junction instead of head on opposing flow, streamline end of header arrangement instead of end headers. Components having lustation troughs should be wide. The type of walls shall support directional changes and at walls. Support should also restrict pipe movements. High pressure and high speed compressor must have pulsion dampers to eliminate pulsion in suction and discharge piping. Impulsing flow must add to piping structure and process equipment. Material fatigue can occur. Damper design is highly specialized and manufacturer recommendation should be followed. Nozzle velocity at inlet and outlets are limited, is 15 meter per second. While planning the layout, provision should be made for this kind of arrangement to consider in complex. Now next is component, that is heat exchangers. The information required for the equipment and piping layout as applied to heat exchangers is the same as that required for any other equipment and has been explained in earlier slides. That is compressors, pumps. Then see the equipment layout. The position of an exchanger, here heat exchanger in a chemical or petrochemical plants depends on the location of the distillation vessels or columns. The relative position should be evaluated from the process flow diagram we call PFD. So then we'll apply some general concepts for locating the heat exchangers. Now the first concept for locating the heat exchanger is heat exchanger should be located adjacent to the related equipments. For instance, instance, reboiler should be located attached or next to their respective towers. Condenser should be located next to reflex drum close to tower. Heat exchanger should be close to the other process equipment in case of draw of flow through an exchanger from a vessel or reactor bottoms. The exchanger should be close to and under the vessels or reactors to have short pump suction lines. Overhead condenser shall be placed above the reactor to handle flows. Now, next concept, the heat exchanger, that is exchanger connecting two equipments, one on cell side and other on the tube sides, located at a distance, should be placed where two streams meet and on that side of the yard where majority of related equipment is placed. The heat exchanger between process equipment and the battery limit, for example, product cooler, should be located near the battery limit to reduce a pipe run. The stack those exchanger which can be grouped together to simplify piping and save plot space. Leave space and access around the exchanger flanges and heads and tubes, bundle cleaning or pooling space in front and in line with the cell. While locating heat exchanger in a row, arrange the saddle to have more economical overall, that is line up or combine foundation or structure design. Further, traveling gantry can be provided in such a that case can be handle a row of exchangers. The heat exchanger shall be located in the equipment layout with respect to the fixed saddle, and the same is located closer to the head. Outline the clearance and working space in front and around both ends of the exchanger to facilitate cell cover and tube bundle removal as well as maintenance and cleaning. The channel end shall face the roadside for convenience of tube removal and the cell cover the rack side. The various clearance shall be indicated in piping layout. So here you can see the uh, various clearance, the heat exchangers concern the equipment layouts, that is clearance between bottom of pipe and grade for drain walls, and clearance between exchanger flange and concrete plane, that is 75 millimeters. So here all dimensions are given in millimeters. You can see the clearance between pipes and top of the wheels and cover removed space is considered for future expansions. There is pull piece for tube turbine, tube bundle access. So here we have to provide the future expansion areas. And the second sketch, you can see the clearance are essential around cell and tube heat exchanger for easy of installation and maintenance. So all dimensions are in millimeters. Now, so let's concern the piping arrangement. This particular heat exchanger. Then, in piping arrangement, the piping engineer is responsible for the physical arrangement of pipings. Most often, the piping engineer will have no influence in the selection of exchangers He can only modify the nozzle arrangements to have an economical pipings. For this, the basic knowledge of this type of exchanger and its construction details are required as per the TEMA, that is TEMA, means Tabular Manufacturer Association. The Tabular Exchanger Manufacturer Association, we call TEMA. It specifies the various combinations the exchangers are used in chemical process industries. Therefore, we have to consider basic types used in the chemical process industries. Fixed tube heat exchangers. So, in this fixed tube heat exchangers, exchangers with complete enclosed tubes are mainly used in clean services. Cleaning can be done by flushing through the tube side and the sail sides. Clean out connection are provided in the piping between the exchanger nozzle and block walls. The bolted cover and channel facilitate the inspection and physical cleaning of the tubes. When used in high temperature services, an expansion joint is built into the cell to take care of the differential expansion between the cell and the tube. Now, second basic type used in chemical process industry is U-tube heat exchangers. In U-tube heat exchanger, the tube bundle is hairpin shape and can be freely expanded. The bundle is removable from the cell and provision in layout has to be made for the same. This type is used when fouling inside the tube is not expected. Now, next type is a floating head type heat exchanger. In this type, the fixed sheet tube sheet and U tube type exchangers are used. But this is a more expensive. Therefore, we can use floating type head heat exchanger instead of fixed tube sheet and U type heat exchangers. One end of the tube bundle has stationary tube sheet held between sail and channel flanges. The floating head can freely expand and contact with temperature changes. Now, next type is kettle type heat exchangers. For high evaporation rates, kettle type heat exchanger are chosen. The cell is expanded to accommodate the generated vapors. This type generally has U2 bundles. The basic principle adopted in the heat exchangers are: the working space should be kept clear of any piping and accessories to facilitate channels, cell cover, and tube bundles removal, as well as maintenance and cleanings. Excessive piping strains on the exchanger nozzles from the actual weight of pipe and fitting and from forces of thermal expansion should be avoided. The piping shall be arranged in such a way that no temporary support will be required for removing the channel and tube bundles. And next principle is provide easily removable spool pieces, flange, elbows, brake flanges, or short pipe runs to provide adequate clearance for the operation of tube renewals. The pipelines with valves and control valve should run along with the access SL close to the exchanger. Pipeline connecting the exchanger with adjacent process equipment can point to point just above required headrooms. The steam lines connecting the header on the rack can be arranged on either side of the exchanges. Walls handle should be made accessible from the grate and from accessway. This accessway should be used for arranging manifolds, control valves, stations, and instruments. To avoid condensate drainage towards exchanger, the prepared connection for steam line is the top of the header. However, there is nothing wrong in having a steam connection from the bottom of the header if steam traps are placed at the low points. So, this is all about the piping arrangement of heat exchangers. Now, we'll continue remaining then onwards in next session. If you have any questions, any doubts, you can ask your. Yes, anyone, any questions? Rakesh,
No, sir.
Prabhul,
No,
Athar?
sir, no doubt.
No, sir. No.
Okay. Then we'll close this session here and we'll continue in next session.